All right, so now when finding the variance of the difference, you still add them. You don't subtract them. And here's why. If we go back to our height activity we did a long time ago, and say the class average was 72 inches. Okay? I think we did the males, so it's a little bit higher. When I had you guys say, imagine you wearing 6-inch heels, the average now was at 78 inches, right? But did the standard deviation change? No. We just picked this thing up, moved it over, and had the same amount of spread. Well, the same thing would happen if we subtracted a number. Okay? If I found a way to make you all shrink by 6 inches, and the average is now over here at 66 inches, I'd still pick this up, move it over, and once again, the standard deviation would be the same, whether I add or whether I subtract. Okay, so that's kind of what's happening with the variance and the standard deviation. It's going to be the same whether we combine them by adding them or we combine them by subtracting. Okay. All right, so calculate the mean and standard deviation of the difference and the amounts that Pete and Aaron collect on a randomly chosen day. Here's the mean. We already have this information from before. They gave it to us here, and we've calculated it. So we'd subtract these. Okay, so in the long run, or on average, Pete averages $20 more than Aaron per day. Okay. For the standard deviation, we would add the variances. Pause if I'm going too fast. So the square roots of the difference in money collected is here. And there's the interpretation. Okay. Okay, move on to the next page. Okay, these are the last 2 pages in the book. They're good examples. They're tough problems. Makes you put on your big boy or big girl AP Stats pants because they're big problems. All right, so first of all, you need to realize that any sum or difference of independent normal random variables is also going to be normally distributed once you combine them. So if it's normal to begin with, each of them separately, it will be normal once you combine them. Okay, something you can count on. All right, pause to read this. All right, so this gentleman has a target of 8.5 to 9 grams of sugar for him to love his tea. Okay, so that's what we're looking for. And what you got to recognize here that these packets, when you add these together, we're combining normal random variables, all 4 of them together. Okay, so what is going to be the mean total for the weights of the sugar? 2.17. It's happening 4 times. Okay, so in short, 4 times that, of course, we get 8.68 grams. What about the standard deviation? Well, they gave us the standard deviation, but we can square it to get the variance, and we do that 4 times as well. Okay, so we end up with 0.16 grams. Now we have the center and the standard deviation, and we can figure out the probability of him getting the tea just right. And here it is. Okay, so for all 4 packets, we're looking for the likelihood of being between 8.5 and 9. And that produces 0.847. Okay, so in the long run, or after, this is probably the best way to do it. In the long run, we expect the sugar to be between 8.5 and 9 grams about 84.7% of the time. Okay, remember, sometimes sugar packets don't have the right amount. That's kind of the idea here. It's not always 2.17. Some of them might be a little higher, a little lower. So sometimes you might be high in the sugar, might be low on the sugar. But most of the time, right, a high proportion of the time, they get it right. Okay, last one. Again, this is in the book. I would encourage you to read. The authors are saying too, but this is now just a difference one. Pause to read it if you need to. I'm going to keep going. Okay, so the mean difference the mean difference between the lid and the cup is 0.02. Okay. Here's the standard deviation. Okay. All right, now this part's pretty important. The lid minus cup. All right, This is when you get 0. Think about it. Something like if the lid was 3.97 and the cup was 3.98, that would be a negative difference. And how are you going to fit a lid that's smaller on the cup unless you really stretch it out? That's not going to fit. So we need it to be 0, but no more than 0.06 on the difference. So, like a 3.99 minus a 3.97 for the cup, that's good. That's a difference of 0.02. That would work. Okay, so we're looking for this range. Okay, so once you get all this information and realize that this is the center and standard deviation, you got to find that boundary, and then we can do the math for that. Okay. All right, that's it for section 6.2. You have a good day.